Name is Brandon Clayton, the Algebra Guy. Thank you for tuning in. Today we'll be discussing, as you see on your screen, how to add mixed numbers step by step. You should be able to solve this by the end of this lesson, so let's get to it. All right, so the question is, how can we model adding mixed numbers? I want to model it for you, drawing some circles, and what are two ways that we can add mixed numbers? So what are those two ways, and how can we model that? So let me pull up my pen, and let's talk about how we can model that. So first of all, let's look at this question. Now, I love how we can talk about money because we all understand it. So what if Ron had $1.25? That'd be 1 1/4. Don had $2.25. That's $2.25. How much do they have together? Well, you could intuitively think about this is just 2 plus 1, right? They got $3 there. So they got $3 plus a quarter and a quarter is 50 cents. And this would be represented as a fraction with 3 and 1/2. Or you could have written it first as 3 2/4 and reduce your 2/4 to 1/2. So, but you end up, either way, you're going to end up there. So that's really the crux of what we're going to be discussing today, is how to add mixed numbers. But you can see the idea there. Now, what would I have done if I wanted to model that? How could I have modeled that? Let's use a different color and think about it. What if I had a circle to represent the 1, like if I shaded this whole thing in, and a 1/4. So this is another circle divided into 4s, and one of those 4s is covered. And then I would add, another 2, 1, 2, and then 1/4 for this one. So divide that into 4s and shade one in. So you can see that when I added all these up, I have 1, 2, 3 whole, and then I have 1/4 and a 1/4. So that's what gave me the 2/4 or 1/2. So you'll see that it's actually a half because I'll shade this other one in from this one, like if I put that there. So 3 and 1/2. So that's what it looks like as a model. And let's look at another model setup, because we're going to start moving some things around to see that you can make sure you get this point. 2 and let's see if another way. I'll just do it this way. 2. So we got a 1, 2, and then a third. So we're breaking this down into thirds, and we want one of those thirds. And then we're going to get our next one and add 1 and 2/3. So we need another one, break that into thirds. Well, we got 2 of these. Now, if you put all these together, how much do we get? So we got 1, 2, 3 whole pieces. And then we got a 1/3 and a 2/3. Well, what is 1/3 and 2/3? 1/3 plus 2/3 is 3/3. What is 3/3? Well, 3 divided by 3 is 1. So that's just the whole thing, because you can see we have one of the thirds here. If these other two connected here, we got a 1 whole piece. So that's actually end up being 3 plus 1, which is 4. So modeling, that's how it will look. So that's what's really going on with these fractions. I want you to have that in your head. What about this one? Let's model this one and give the sum as a mixed number. So we got 1. So that's 1, and then we have 3/5. So we break this into fifths. Looks like a star. And we got 3/5. So 1, 2, 3 plus 2. 1, 2, and then 3/5. So this is going to be broken into fifths again, and that's going to be, let me use a different color. It's easy to see the line separating it. There we go. So this was 3/5. All right, so how much do we have? Let's keep it in the mixed number. We got 1, 2, 3. 1, 1, 2, and 3. So that gives us 3. What about the fraction part? So we got 1, 2, 3, 4, 5, 6. So we got 5. I'm sorry. Yeah, that's right. 6/5. So 1, 2, 3, 4, 5, 6. 6/5, because we divide them into fifths. Now this is an improper fraction. So 6 divided by 5. 6 divided by 5 gives me 1. and 1/5. So this is actually going to turn into 1 and 1/5. So instead of being 3, it's 3 plus 1 and 1/5. So really what I have here is 4 and 1/5, because these little pieces, 1, 2, 3, I needed 2 more to make a whole thing, and then there was still 1 left over. So that gives me 1, 2, 3, 4, and then there's a little piece left over. So that leaves me 4 and 1/5. So that's what's happening with fractions. I want you to get that in your mind, the model of what's really going on, so that we're not just caught up in doing steps. So what did we notice is the rule when we were going through this? So we add the whole numbers, add the fractions, simplify if possible. So that's what we did. We add the whole numbers, we keep adding the fractions, and then we simplify if we could. So that's the pattern. Let's continue that pattern. What happens here? Let's not use the model. Let's just think about what's going on. So we add the whole numbers, right? So that's 3. And if I were to make it vertical, sometimes that helps, plus 2 over 2/9. Yeah, that's a little bit easier to see. You can see that my whole numbers are going to be added here as 5. Check, did that. Add the fractions, 4/9, 2/9. They have the same denominator, which means I can add the numerator. 4 plus 2 is 6 over 9. And then simplify if possible. Well, can I simplify 6 over 9? Well, I can see they both have a 3 in it. So instead of 6 over 9, I'm going to write that over here. I can take out a 3, because that's 3 times 2, and this is 3 times 3. So 3 divided by 3 is 1, so all I have left is actually 2/3. So this is going to be 5 and 2/3. There it is, ladies and gentlemen. That's how we were going to do that. Did I skip one? Yes. So let's do this one. Add the numbers. Same steps. So I want you to pause it here and see if you can do this one by yourself. Sometimes, again, it helps to set it up vertically, especially when they're like denominators. So that's why I'm doing it this way. All right, we're going to add this. First, we're going to add our whole numbers. 9 and 5 gives me a 14. Then I'm going to add the fractions. Well, they're already like denominators, so I can just add the numerator. 7 plus 5 is 12. And add the, just bring down the denominator. I noticed the top is bigger than the bottom. That means I have a whole number in here somewhere that I can take out. So I can take out 9 from this 12, because 9 over 9 is equal to 1. That's going to leave me with 3 over 9. Because if I would have added these, I don't want to do that. Make that confusing. So what I just did was 12 divided by 9 is 1. And it leaves me with 3. So I know it's a 1. So 12/9 is the same thing as 1 and 3/9. So this is end up being 14 and 12/9. Well, 12/9 is plus another 1 and 3/9. 14 plus 1 is 15. And actually, I shouldn't write it this way, because I don't want you to just know that I'm adding a 14, the extra 1 here. 14 plus this 1 that's in here. And what I'm left over is my 3/9. I don't want anyone to be confused. Now, can I simplify this anymore? Well, I do know that my 3 and 9 have a 3 in common. So I divide 3 out of both of these. And it gives me 1 over 3. So that'll be 15 and 1/3. All right, so the next one we're going to do is add by converting the mixed number to an improper fraction. So we're going to just leave it as an improper fraction. Instead of doing it this way, 3 7/8 and 4 3/8, instead of doing it vertically, we're going to change these into a improper fraction first and then add them. So let's see what that looks like. So if I were to do that, that's going to give me, if you remember, 3 and 7/8. Let me make that a little bit bigger. How do I go from a mixed number to an improper fraction? So what I need to do is 3 times 8 plus 7. 3 times 8 is 24. 24 plus 7 is 31. That's over 8. So now I change that to an improper fraction. If you want more practice on that, check out a previous video I've done over just changing mixed numbers to improper fractions. And 4 and 3/8 is going to be handled the same way. 4 times 8 is 32, plus 3 more is 30. 32 plus 3 is 35 over 8. So now instead of writing it this way, we're going to look at it as an improper fraction. So I'm going to make this 3 and 7/8 31 over 8 plus 35 over 8. All right, so this is pretty simple now because I know that when I'm adding, the bottom stays the same, and I just add these two top ones. 31 plus 35 is 66. And I try to simplify if I can. And by converting mixed numbers. So we'll leave it as a improper fraction since that's what they asked us to do. But we can, let me give us some room over here. We can simplify this because I can tell immediately. How can we tell immediately that this can be simplified? Well, they're both even, right? So good. So you got 6 and an 8. They're both least divisible by 2. So we know that can happen. It's not divisible by 8 or 4, so we're at least going to do 2. So I know 66 can be divided into factors of 2 and 33. 2 times 33 gives me that. And 8 can be divided into factors of 2 and 4. Well, now I can see that my 2's are going to cross out, leave me with 33 over 4. There are no factors that 33 and 4 share. So this is all we can end up with. All right, so what you just saw was there's two different ways I could work this. I can work it vertically, or I can work it where I change it in proper fractions and then just add the top. And I'm going to show you both ways with this problem here. So let's use it as mixed number. And the way that is we leave it as a mixed number and just do 2/5. And this is when we have the same denominator. It's really easy to do this. And add 4/5. So the way we just talked about it is add up our whole numbers. 6 and 3 is 9. And then add up our numerators. 4 and 2 is 6 over the 5, because that's going to stay the same. 6 over 5 is the same thing as 6 over 5 is the same thing as 1 and 1/5 when you divide it. So we know this is going to be a 10 because we got another whole 1 and 1/5. So that's one way you could have done it. Now the other way we talked about just recently is to change this to an improper fraction. So let's change that 3 and 2/5 to 3 times 5 is 15 plus 2, 17 over 5 plus 6 times 5 is 30 plus 4 is 34 over 5. And then we just simply add the top. 34 plus 17 looks like it's going to be 51. So that'd be 51 over 5. And I want to just go ahead and write that out so you can see what I did. So I just added those two on the top. So they gave me 51 over 5. And if I wanted to convert that to a mixed number, you can just divide these two again, 51 and 5. 51 divided by 5, 5 goes into there once, 0, and bring down our 1, can't go into there, so we make another 0, and then bring down that 0. 5 goes into 10 twice, 10.2. Actually, we didn't have to go that far. Forgot, we should have stopped right there. We should just stop right here and said 10 and 1/5, which is the same thing right here. We just got 10.2, which is still the same answer as a decimal, but 10 and 1/5 is where you want to stop. Now, whichever way you feel more comfortable, choose that way. This looks a little bit shorter for this problem, but when you feel more comfortable using, I would go with that. But those are two different ways, and you get to pick how you want to work that. But that is it. How can we model adding mixed numbers? So we looked at the circles and how you can combine all the whole circles and then add up its pieces to give us the whole thing. And what are two ways? So we looked at making it into a mixed number leaving it as a mixed number and doing it vertically, right? So we just set it up vertically like this, or we switch them into improper fractions. 13 over 3, and then we just added the tops. Actually, this is supposed to be the same bottom. 9, 10. 10 over 3. I'm just making up a problem so quickly. But this is supposed to be the same denominator because that's what I wanted to practice. 3 times 3 is 9. It's 10 over 3. And then you just add the top piece. So that's a quick review of what we just talked about. Thank you for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.